Okay, before we introduce you to our hardness tester, let's go ahead and talk about what is actually happening as we are measuring hardness. So hardness is the physical quantity that is just resistance to permanent indentation for any given material. A good or high hardness value generally means that the material is resistant to scratching and wear. We care about this particularly in manufacturing because a lot of the tooling that we use to change the shapes of any given material must be hard so that it can last for many cycles, so that it can last and be resistant to scratch and wear as we continue doing these shape forming processes. Hardness testing is commonly used for assessing material properties because it's quick and convenient. There's a large variety of scales and methods due to a wide range of material hardnesses that we actually want to characterize and measure. So, we are going to specifically use the Rockwell hardness test in our lab. The Brunel and Rockwell scales are common for measuring metals because, again, metals have a general known range of hardnesses. However, it's also possible to measure the hardness of things that are relatively soft. Even things like biological tissues, elastomers, and polymers are plastics, right? You can also measure those hardnesses, except we're going to use different scales. And so the key thing would be we would use the Vickers, Knoop, Slarescope, or consider the durometer of one of those materials as another type of hardness scale. Okay, but as I mentioned in this lab, we're very focused on using the Rockwell hardness test. In fact, we have a Rockwell hardness tester in the metrology lab in the Idea Forge. As noted, it is widely used. And the process here is we're going to take an indenter and we're going to insert it into our specimen using a set minor load. In our case, we're going to use the Rockwell hardness B scale, and that minor load happens to be 10 kilograms. That initial minor load seats the indenter in the material a certain amount. Then we're going to stand back and let the machine apply a major load, in this case of 100 kilograms. This causes the indenter to go deeper into the material. It penetrates beyond that initial position. The machine looks at that additional distance that major load causes the indenter to further go into the material, and it converts that into a Rockwell hardness reading in the testing machine itself. So that's what we mean. Rockwell hardness testing is quick and easy. You set the minor load, and then the machine does the major load and gives you a number. Okay. The one key difference, right? This machine or this image is showing you a cone-shaped indenter. For the Rockwell B scale, we actually use a ball indenter that is a 1/16 inch ball bearing rather than this cone shape. Okay. However, this detail of minor load 10 kilograms, major load 100 kilograms, that is correct for the Rockwell B scale. Okay. A couple other quick details. It is possible to also talk about a given material's harden ability, and that is describing specifically for steels the relative capacity of a steel to be hardened by transformation to martensite. Key thing is it determines the depth below the quenched surface to which the steel is hardened because a lot of times we care about the edges, right? The outer shell or case of a material to think about how far can we actually get this case hardening approach to take effect within our material. Steels with good hardenability can be hardened more deeply below the surface, and there's a lot of other fancy tests and details that we can get into. Key thing for you all to take away, hardenability does not refer to the maximum hardness of a material that can be attained, but rather the depth of hardness. Keeping in mind that hardness may not be homogeneous throughout an entire material, sometimes it may be just on the edges. Okay. Okay.